Welcome to this quiet space, a place for gentle stories from the universe to help you drift into a peaceful sleep. Tonight, we begin a journey to a world that feels both infinitely distant and as close as a familiar face in the window. We will travel to our silent companion, the moon. Before we begin this journey into the soft glow of the night, I would love to know where you are listening from this evening and what the moon looks like from your corner of the world. Please feel free to share in a comment below. And if you find a moment of peace here, please support our channel with a like and subscribe so we can continue to share these stories with you. Thank you so much. And now, let us begin. Settle in and let your breath slow down. Let the sounds of your day begin to fade, replaced by the stillness of the night. Perhaps through a window, or perhaps just in your mind's eye, you can picture it now. The moon. It hangs there in the velvet darkness, a luminous anchor in the vast, shifting sea of stars. It is the first celestial body we recognize as children, the one we point to with wonder, its presence a simple and profound truth of our world. It feels like ours, a part of our home, yet it is a world unto itself, a sphere of ancient rock and dust, sailing through the silent emptiness of space. This celestial body, so woven into the fabric of our nights, is Earth's only natural satellite, a constant partner in a gravitational dance that has unfolded over billions of years. It does not simply adorn our sky, it is fundamentally bound to us, circling our planet in a journey that is both unending and ever-changing. This journey is not a perfect circle, but a gentle ellipse, a path that brings our companion closer and then lets it drift farther away. At its closest point, known as perigee, the moon comes to within about 363,000 kilometers of Earth, appearing just a little larger and brighter in our sky, a subtle emphasis in its silent conversation with us. Then, following the graceful curve of its orbit, it swings out to its farthest point, apogee, a distance of nearly 406,000 kilometers, a slightly more distant, more modest pearl against the cosmic black. On average, it keeps its vigil at a breathtaking 384,400 kilometers away, a distance so vast that all the other planets in our solar system could fit side by side in the space between us. And yet, despite this immense gulf, its presence feels as immediate as a lantern lit just outside our door. This orbital dance, this slow and steady rhythm, is what creates the moon's most mesmerizing and familiar characteristic. Its changing phases. We watch it, night after night, as it appears to grow and shrink in a silent, luminous performance. It begins as a new moon, a dark disk lost in the glare of the sun, its illuminated face turned completely away from us, a moment of cosmic quiet. Then, a delicate sliver emerges, a waxing crescent, like the universe has taken a single, shining brushstroke against the dark canvas of the sky. This sliver grows, night by night, into the first quarter, a perfect half-moon, a stark division of light and shadow, as if showing us two possible worlds at once. It continues its journey into a waxing gibbous, becoming heavy with light, until it finally arrives at its most magnificent state. The full moon. It rises like a great, glowing lantern, bathing the landscape in a soft, ethereal light, its entire Earth-facing side illuminated by the sun. This is the moment we feel its presence most acutely, a luminous reassurance in the deepest part of the night. But this fullness is not forever. The light begins to recede, the waning gibbous giving way to the third quarter, another perfect half, but this time a mirror to the first. The light continues to fade through the waning crescent, a final, delicate sliver of silver, until the moon once again disappears into the darkness of its new phase, ready to begin the cycle anew. This endless sequence is not the moon itself changing, but rather a beautiful illusion created by our own shifting perspective. The phases are simply the geometry of light, the result of where the moon is in its orbit around us, and how much of its sunlit half we are able to see from our terrestrial vantage point. This cycle, from one new moon to the next, takes approximately 29.5 days, a measure of time we have come to know as a month. For countless generations of our ancestors, this was the first and most reliable calendar, a celestial clock that marked the passing of seasons, the time for planting and for harvest, its rhythm woven into the very foundation of human culture and our first attempts to understand the cosmos. The moon was our first guide to the vastness of time, its luminous face a story told in the universal language of light. And it is this light, this gentle, changing glow, that so captivates our imagination. That gentle, changing glow, which seems to pour down from the lunar surface and pool in the quiet corners of our world, holds a secret of its own. We call it moonlight, but it is not of the moon. The soft, silvery luminescence that has inspired poets and guided travellers through the ages is not born from the moon itself, for our companion is a world of cold, dark rock, with no internal fire to light its way. The light it gives us is a borrowed light, the gentle whisper of the sun's distant fiery roar. The moon acts as a celestial mirror, catching the brilliant light of our star and reflecting it across the gulf of space to our waiting eyes. But it is not a perfect mirror, like one of polished glass. It is more like a very old, very weathered stone, its surface ground down by eons of cosmic sandblasting. This property, the measure of how much light a surface reflects, is known as albedo. A perfect mirror would have an albedo of 1, reflecting all light that strikes it, while a perfectly black surface would have an albedo of 0. The moon's albedo is surprisingly low, only about 0.12, which means it reflects a mere 12% of the sunlight that falls upon it. In reality, the surface of the moon is incredibly dark, with the colour and reflectivity of worn asphalt or a dusty piece of charcoal. So why does it appear as such a brilliant beacon in our night sky? The answer lies not on the moon, but in the space that surrounds it. It shines so brightly only because it is set against the perfect, profound blackness of space. Its muted reflection is amplified by the absolute darkness of its backdrop, a single, dimly lit object in an otherwise empty room, which our eyes perceive as a source of brilliant light. This borrowed light is further transformed on its journey to us. As the rays of sunlight bounce off the lunar surface and travel the long road to Earth, they must pass through the very thin, uppermost reaches of our own atmosphere. Here, a subtle effect takes place, the same effect that paints our skies blue and our sunsets a fiery red. This phenomenon, known as Rayleigh scattering, occurs when light interacts with particles that are smaller than its own wavelength. Blue light, with its shorter wavelength, is scattered more easily than red light. When the moon is high in the sky, its light takes a direct path through the thinnest part of the atmosphere, and this effect is minimal, allowing it to appear a stark, silvery white. But when the moon is low on the horizon, during moonrise or moonset, its light must travel through a much thicker slice of Earth's atmosphere. During this longer journey, more of the blue light is scattered away, leaving the longer, warmer wavelengths of yellow, orange, and red to reach our eyes. This is why a rising harvest moon can appear a deep, dramatic orange or a soft, golden yellow, its colour not a property of the moon itself, but a blush given to it by our own planet's airy veil. The moon's light is not just a reflection, but a message that has been filtered and coloured by its passage through our world. And the final transformation, the one that gives moonlight its unique magic, happens within us. It happens in the quiet biology of our own eyes. As day turns to night, our vision undergoes a remarkable shift. In bright daylight, we rely primarily on the cone cells in our retinas, which are brilliant at perceiving fine detail and a rich spectrum of colour. But as the light fades, the cone cells become less effective, and our eyes switch over to a different set of photoreceptors. The rod cells. These rods are incredibly sensitive to low levels of light, allowing us to see in near darkness, but they are mostly colorblind. This transition is known as the Purkinje effect. It is the reason why a vibrant, colorful garden seen at noon becomes a landscape of shimmering silvers and deep, soft shadows under the light of a full moon. The magic we perceive, the ethereal, desaturated quality of a moonlit world, is a collaboration between the cosmos and our own neurobiology. The moon provides the faint illumination, and our eyes, in their ancient wisdom, interpret that light in a way that feels dreamy and mysterious. The silver world we see is a world painted by our own senses, a personal masterpiece created at the threshold of vision. The moon's light, therefore, is a story in three parts: a star's fire, a world's reflection, and a human's perception. This light touches the surface of our world, painting the leaves of trees in silver and laying shimmering paths across the water. But the moon's connection to us is deeper than this visible light. It is an invisible touch, a silent pull that reaches into the very heart of our oceans. This visible light, which paints our world in shades of silver, is only the most delicate of the moon's connections to us. There is another, an invisible touch, a silent and persistent force that reaches far deeper than the surface of the water. It is a pull that stirs the very heart of our oceans, a gravitational whisper that coaxes them into a slow, planetary-scale breath. This is the force of the tides, a rhythm so steady and so ancient that the earliest life on Earth evolved in its ebb and flow. The source of this immense power is the same fundamental force that holds the moon in its orbit and anchors our feet to the ground: gravity. As Sir Isaac Newton first described, every object in the universe exerts a gravitational pull on every other object, a mutual attraction that is stronger the closer and more massive the objects are. The Earth and Moon are locked in this constant embrace, a field of invisible force binding them together across the 384,400 kilometers of empty space. But this gravitational embrace is not uniform. The Moon's pull is subtly stronger on the side of the Earth that is currently facing it, and it is subtly weaker on the side of the Earth that is turned away. The solid body of our planet can resist this differential pull, but the liquid water of our oceans is free to respond. The result is a gentle stretching of our world. On the side nearest the Moon, the water is pulled toward it, creating a high tide, a bulge of water reaching out into space. And here is the beautiful counterintuitive truth. On the side of the Earth farthest from the Moon, another high tide is formed at the very same time. This happens because the Moon is pulling the solid Earth away from the water on that far side, leaving it to bulge outwards as well. Our planet, dressed in its liquid oceans, becomes slightly elongated, a sphere stretched into a gentle oval by the Moon's constant, tidal caress. As the Earth spins on its axis, we on the surface are carried through these two bulges of water each day, experiencing the rhythm of two high tides and two low tides. It is a planetary scale breathing, a slow and silent inhalation and exhalation of the seas, all conducted by our distant, silent companion. But the Moon is not the only conductor in this celestial orchestra. The Sun, with its immense mass, also exerts a powerful gravitational pull on the Earth. Although the Sun is vastly more massive than the Moon, it is also almost 400 times farther away, which significantly weakens its tidal influence to less than half of the Moon's. Yet, its contribution is still profound. When the Sun, the Earth, and the Moon align, which happens during the new moon and the full moon, their gravitational forces combine. The Sun's pull reinforces the Moon's, and the tidal bulges become larger than usual. These are the spring tides, a time of the highest high tides and the lowest low tides, when the ocean's breath is at its deepest. Conversely, when the Moon is in its first or third quarter, it forms a right angle with the Sun and the Earth. During these times, the Sun's gravity pulls on the oceans at a different angle from the Moon's, partially cancelling it out. This results in the neap tides, a period of more moderate tides, when the difference between high and low water is at its smallest, as if the ocean is taking a shallower, more restful breath. This complex interplay of cosmic forces, this gravitational harmony, has shaped our world in ways far more profound than the daily lapping of waves on a shore. Over immense geological timescales, this constant tidal friction, the drag of the ocean bulges against the spinning Earth, has been acting as a gentle brake. Inconceivably slowly, the Moon is stealing rotational energy from our planet, causing the length of our day to gradually increase. Hundreds of millions of years ago, a day on Earth was only about 22 hours long. The Moon, through the patient work of the tides, has given us the longer days we know now, and continues to add about 1.7 milliseconds to our day every century. The ocean's breath, orchestrated by the Moon, is slowly and peacefully reshaping our planet's relationship with time itself. And as we contemplate these vast, liquid seas of Earth, stirred by an invisible hand, our gaze is drawn back upward to the moon, to the dark and tranquil patches on its face that our ancestors once named seas of their own. Those dark patches, which resolve into the familiar shapes of a face or a rabbit or a figure reading a book, were named Maria, the Latin word for seas, by early astronomers like Galileo. Gazing through their first simple telescopes, they saw vast, smooth, dark expanses that contrasted sharply with the bright, rugged terrain surrounding them, and they imagined they were looking upon great lunar oceans, perhaps of water or some other, more ethereal substance. The names they gave them are pure poetry. Mare Tranquillitatis, the Sea of Tranquility; Mare Imbrium, the Sea of Rains; and Oceanus Procellarum, the Ocean of Storms. We know now that these are not seas of water, but seas of a different kind. They are immense, ancient plains of frozen lava. Their story begins in the violent youth of our solar system, more than 4 billion years ago, a time when colossal asteroids and comets rained down upon the newly formed worlds. The young moon was pummeled by a series of titanic impacts, collisions of such unimaginable force that they shattered the lunar crust and gouged out enormous basins, some over 1,000 kilometers wide. For hundreds of millions of years, these colossal scars remained. But deep within the moon, its interior was still hot and molten from its formation. This subterranean magma, rich in iron and magnesium, slowly welled up through deep fissures in the crust, eventually pouring out onto the surface and flooding the great impact basins. This dark, basaltic lava flowed like thick honey, burying the older craters within the basins and creating the vast, relatively smooth, and dark surfaces we see today. The Luna Maria are the healed wounds of the moon's ancient past, vast plains of dark, volcanic rock that tell a story of cosmic violence, followed by a deep and enduring peace. In stark and beautiful contrast to these dark, youthful seas are the lunar highlands. These are the bright, rugged, and heavily cratered areas that make up the majority of the moon's surface, especially on its far side. Known as terrae, the Latin for lands, these are the moon's original, primordial crust, a landscape of breathtaking antiquity, composed of a lighter-coloured, lower-density rock called a northosite. The highlands are the very first material that solidified from the great magma ocean that once enveloped the entire moon shortly after its birth. Because they are older and were never flooded by lava, the highlands bear the full, unvarnished record of the solar system's early chaos. They are battered and saturated with craters, overlapping and intersecting, telling a 4.5 billion-year-old story of relentless bombardment. This entire lunar landscape, both the dark Maria and the bright highlands, has been sculpted almost exclusively by one relentless artist. Impact cratering. With no atmosphere to burn up incoming projectiles and no wind or water to erode the scars, every impact is preserved with stunning clarity. From tiny micrometeorite pits to sprawling basins, each crater is a frozen moment of cosmic violence. We can see their entire structure: the raised, circular rim, the bowl-shaped depression, the central peaks that rebound in larger impacts, and the delicate, feathery rays of ejected material that can stretch for hundreds of kilometers across the lunar surface, like a splash of white paint on a dark canvas. It is a landscape of profound silence and stillness, yet one that speaks of unimaginable energy. And in our quest to understand this world, we have given names to its most prominent features, creating a map not just of geology, but of human curiosity. We have named the great craters after the titans of science and philosophy: Copernicus, Kepler, Plato, Archimedes, etching the memory of our own search for knowledge onto the face of the world that first inspired it. In doing so, we have made this alien landscape a part of our own story. Its mountains and seas, a testament to both its own ancient history and our enduring wonder. The sharp, black shadows cast by the rims of these craters and the peaks of these eternal mountains create a world of stark and dramatic contrast, a chiaroscuro world where the boundary between light and darkness is absolute, a principle that finds its most awe-inspiring expression when these shadows are cast not upon the moon, but across the face of our world, or our sun. The stark and absolute shadows that define the lunar landscape cast by crater rims and lonely mountains, are a constant reminder of the unfiltered nature of light in space. But there are moments, rare and breathtaking, when the moon and the earth cast their own shadows upon one another, creating the most sublime and awe-inspiring spectacles in our sky. Eclipses. These are not mere shadows. They are moments of perfect geometric alignment, a cosmic syzygy where the sun, moon, and earth fall into a single, straight line across the void. The fact that this happens at all is a miracle of celestial coincidence. The sun is a star of immense size, about 1.4 million kilometers in diameter, while our moon is a comparatively tiny world, less than 3,500 kilometers across. The sun is, in fact, almost exactly 400 times larger than the moon. But, in one of the most beautiful coincidences in our solar system, the sun is also almost exactly 400 times farther away. This precise ratio of size and distance means that from our vantage point on Earth, the tiny moon and the colossal sun appear to be the exact same size in the sky. This cosmic accident is what makes possible the profound beauty of a total solar eclipse. As the new moon passes directly in front of the sun, its dark silhouette slides across the brilliant solar disk. The world does not fall instantly into darkness, but the light begins to fade in a strange, unsettling way. The colors of the landscape become muted and desaturated, the air grows cooler, and an eerie twilight descends. Animals grow quiet, confused by the premature dusk. And then, for a few brief, wondrous minutes, the moon perfectly covers the sun's bright face, the photosphere. Night falls in the middle of the day, and in that moment of manufactured darkness, the sun's greatest secret is revealed. Its magnificent outer atmosphere, the corona. This halo of ethereal, pearlescent light, 1,000,000 times fainter than the sun itself, is a plasma of superheated gas that streams millions of kilometers out into space. It is a sight of impossible, ghostly beauty, ordinarily invisible to us, but revealed in its full glory by the moon's passing shadow. Just as the moon can cast its shadow upon the Earth, so too can the Earth cast its own, much larger shadow into space. When the full moon, in its orbit, happens to pass through this terrestrial shadow, a lunar eclipse occurs. This event is a more gentle and prolonged affair. There is no sudden darkness, but rather a slow, creeping stain that begins to move across the luminous face of the moon. As the moon slides deeper into the Earth's dark, central shadow, the umbra, it does not usually disappear entirely. Instead, it is often transformed, its familiar silvery glow replaced by a faint, ghostly, and often beautiful, coppery red light. This ruddy illumination is a celestial echo of our own world. It is the light of every single sunrise and every single sunset on Earth, all happening at that same moment, being bent and filtered through our planet's atmosphere and projected onto the face of the moon. To stand on the moon during a lunar eclipse would be to see the Earth as a dark circle, ringed by a delicate, fiery halo of every dawn and every dusk, the combined light of which is just enough to paint the lunar landscape in a soft crimson glow. These magnificent alignments, however, are rare. If the moon orbited the Earth in the exact same plane that the Earth orbits the sun, we would experience a solar eclipse at every new moon and a lunar eclipse at every full moon. But the universe is rarely so simple. The moon's orbit is tilted at a slight angle, just over 5 degrees, relative to Earth's orbital plane. Because of this tilt, the moon's shadow usually passes harmlessly above or below the Earth during a new moon, and the moon itself usually passes above or below the Earth's shadow during a full moon. Eclipses can only occur during 2 specific periods each year, known as eclipse seasons, when the Earth, moon, and sun are all perfectly aligned on that tilted plane. It is only then that the shadows can meet, the dark umbra finding its mark to create a total eclipse, or the fainter, penumbral shadow creating a more subtle dimming. For our ancestors, these events were often terrifying portents, moments when the familiar order of the cosmos seemed to break down. But for us now, they are moments of profound connection, a time to witness the silent, graceful, and predictable mechanics of our solar system, a celestial clockwork that reminds us of our own small but beautiful place within a universe of immense and wondrous shadows and light. And this sense of wonder, of witnessing such perfect celestial geometry, leads us to an even deeper question. What cosmic event, what grand alignment of forces could have possibly created this perfect companion for our world? The question of where the moon came from, how this enormous satellite came to be our constant companion, is one of the most fundamental questions we can ask about our place in the cosmos. For centuries, it was a profound mystery, giving rise to many elegant but ultimately flawed ideas. Some thought the early, rapidly spinning Earth flung a piece of itself into space, leaving behind the Pacific Ocean basin as a scar. Others imagined that the moon was a wandering body, a lonely traveller through the solar system that was captured by Earth's gravity. But none of these stories quite fit the evidence we gathered once we could hold a piece of the moon in our hands. The truth, as we now understand it, is far more violent and far more poetic. The leading and most widely accepted story of the moon's birth is called the giant impact hypothesis, and it begins in the chaotic dawn of our solar system, some 4.5 billion years ago. At this time, the Earth itself was just a protoplanet, a sphere of molten rock still gathering itself together. And it was not alone. The early solar system was a crowded and dangerous place, filled with dozens of small aspiring planets on unstable, intersecting orbits. One of these primordial worlds, a body roughly the size of modern-day Mars, has been given the name Theia, after the Greek Titan who was the mother of the moon goddess, Selene. Theia's orbit brought it onto a collision course with our young Earth. The impact was not a head-on-head collision, but a glancing blow of unimaginable scale. In a cataclysm that unfolded over mere hours, Theia struck the molten Earth, its own body, and a huge portion of Earth's mantle being utterly vaporized by the sheer energy of the collision. The iron core of Theia, being dense and heavy, plunged inward and merged with the Earth's own core. But the lighter, silicate rock from both bodies was blasted into space, not escaping entirely, but forming a vast, searingly hot ring of vaporized rock and debris that encircled our wounded planet. For a time, the Earth would have looked like a small glowing star with a brilliant, incandescent ring, a temporary and violent echo of the planet Saturn. But this ring was not destined to last. Within this cloud of debris, gravity immediately went to work. Particles of vaporized rock began to cool and condense, and these small particles began to stick together. Clumps grew into boulders, and boulders smashed together to form moonlets kilometers across. A gravitational chain reaction began as the largest of these bodies swept through the ring, pulling in more and more material, growing ever larger in a process called accretion. Over a remarkably short period in cosmic terms, perhaps as little as a few decades or centuries, the vast majority of this debris ring was swept up and coalesced into a single, massive body. Our moon was born. It would have formed incredibly close to the Earth, perhaps 20 times closer than it is today, appearing as a monstrous, terrifying sphere in the primordial sky. And it was born hot, a global ocean of molten magma, glowing with a dull, angry, cherry-red heat, its surface a turbulent sea of liquid rock. This was the violent and fiery crucible in which our silent companion was forged. This single, cataclysmic event elegantly explains so many of the moon's mysteries. It explains why the moon has such a small iron core. Most of the heavy iron from both Theia and Earth remained with our planet. It explains why the moon is made of rock that is so chemically similar to Earth's own mantle, sharing a unique isotopic fingerprint that points to a common origin. And it explains why the moon began its life covered in a magma ocean, a fact that is crucial to understanding the formation of its two distinct types of crust, the highlands and the maria. From a moment of almost unimaginable destruction, a partnership was born, a relationship that would shape the destiny of our world, beginning with the slow cooling and solidification of that newborn, molten sphere. From that single, cataclysmic moment of creation, the story of the moon became one of cooling, of a slow and steady settling that continues to this day. The newborn moon, a global ocean of incandescent magma, did not remain a homogeneous sphere for long. As it began to radiate its primordial heat into the coldness of space, a magnificent planetary-scale process began to unfold. Differentiation, Just as oil separates from water, the various elements within the molten moon began to separate according to their density. The heaviest elements, primarily iron and nickel, felt the inexorable pull of gravity and slowly began to sink toward the center, a journey through thousands of kilometers of liquid rock. At the same time, the lighter materials, silicate minerals rich in aluminum and calcium, floated upwards, like cream rising to the top. Over millions of years, this slow, gravitational sorting created a layered, structured world. At its very center, the iron formed a dense core. Floating above this core is the largest part of the moon, the mantle, a vast region of denser silicate rocks. And on the very top, the lightest minerals cooled and solidified to form the moon's primordial crust. This is the fundamental architecture of all rocky worlds, a blueprint written by the universal language of physics and gravity. But the moon's version of this story has a unique and telling feature. Its heart, its metallic core, is remarkably small. While Earth's core takes up more than half of our planet's diameter, the moon's core is a mere 20% of its own. It consists of a solid inner sphere of iron, about 480 kilometers in diameter, surrounded by a liquid outer shell that extends to about 660 kilometers. This iron-poor heart is a direct inheritance from its violent birth. The giant impact hypothesis tells us that when Theia struck the Earth, the dense iron cores of both planets merged and were mostly retained by the larger, more massive Earth. The moon was formed primarily from the lighter, silicate-rich mantle material that was blasted into orbit, leaving it with only a small portion of its parent body's iron. This seemingly simple detail of its internal structure has a consequence of profound importance. On our own world, the massive, churning, liquid iron outer core acts as a colossal dynamo. The convection currents within this molten metal, combined with the planet's rotation, generate a powerful, global magnetic field. The magnetosphere, this invisible shield, envelops our planet, extending tens of thousands of kilometers out into space, protecting us from the constant stream of charged particles in the solar wind and deflecting the most dangerous cosmic rays. It is this protective bubble that has allowed Earth's atmosphere to remain, and perhaps for life itself to flourish, safe from the stripping effects of solar radiation. The moon, with its small and sluggish core, has no such shield. While there is evidence that in its distant youth, when it was hotter and its core was more dynamic, it may have sustained a weak magnetic field for a time, that ancient dynamo has long since fallen silent. Today, the moon faces the cosmos utterly exposed. The solar wind, that unceasing gale of protons and electrons flowing from the sun, strikes its surface directly, implanting itself into the very soil. There is no atmospheric blanket to burn up meteoroids, no magnetic shield to deflect harmful radiation. The moon is a world of brutal, unfiltered truth, its surface a testament to billions of years of direct exposure to the harsh realities of space. This quiet, iron-poor heart has defined its destiny, making it the silent, preserved, and beautifully vulnerable world we see today. And this state of being, this direct and unprotected relationship with the cosmos, is mirrored in the intimate and unchanging way it presents itself to the Earth. This quiet, geologically settled world, with its still and silent heart, has also settled into a uniquely still and silent relationship with our own planet. For as long as human beings have looked up at the night sky, we have seen the same face looking back at us. The familiar patterns of the dark Maria and the bright highlands, the face of the man in the moon, is a constant. We never see the other side. This has led to the romantic but misleading phrase, the dark side of the moon. But there is no perpetually dark side. The side we cannot see, more accurately called the far side, experiences the same cycle of day and night as the near side we know so well. As the moon orbits the Earth, every part of its surface is bathed in sunlight for 2 weeks, and then plunged into the cold of night for 2 weeks. The far side is not dark, merely hidden from our view, a secret hemisphere that remained a complete mystery to humanity until a Soviet space probe first photographed it in 1959. The reason for this constant gaze, this perfect and perpetual facing, is a beautiful phenomenon known as synchronous rotation, or more commonly, tidal locking. It is the end result of a long and patient gravitational conversation between the Earth and the Moon. In its youth, the Moon spun on its axis much more rapidly than it does today. But it was also much closer to the Earth, and our planet's immense gravity exerted a powerful tidal pull on it. Just as the Moon raises tides in our oceans, the Earth raised tides on the Moon. In its early molten state, these would have been colossal tides of liquid rock, creating two prominent bulges on the lunar surface. The Earth's gravity then tugged relentlessly on these bulges, one on the near side and one on the far side, creating a torque that acted as a powerful brake. This constant gravitational friction steadily and inexorably slowed the Moon's rotation over hundreds of millions of years. The process continued until the Moon's rotational speed had slowed down so much that it perfectly matched the speed of its orbit around the Earth. It now takes the Moon the exact same amount of time to spin once on its axis, about 27.3 days, as it does to complete one full orbit around us. The result is this perfect synchrony, its constant gaze, where one hemisphere is now permanently locked to face the Earth. This stable, locked state was also encouraged by the Moon's own physical asymmetry. The Moon is not a perfectly uniform sphere. Its center of mass is slightly offset from its geometric center, and its crust is significantly thicker and denser on the far side. This lopsidedness made it easier for Earth's gravity to grip one side more than the other, encouraging it to settle into this lowest energy, most stable orientation with its thinner crusted, slightly bulging near side facing us. And this asymmetry created two fundamentally different worlds on one celestial body. The near side, our familiar friend, is the face we know. Its thinner crust allowed the magma from the interior to easily well up and flood the great impact basins, creating the vast, dark maria that dominate its appearance. It is a world of dramatic contrasts. The far side, however, is a different realm. With its thicker crust, it was much more difficult for magma to reach the surface. Consequently, it has very few maria and is almost entirely covered in the bright, primordial, and densely cratered highlands. It is a more ancient and uniformly battered landscape, a testament to the solar system's violent beginnings. Seeing it for the first time was like meeting the twin of a dear friend, someone who shared the same origin but had lived a completely different life. It is a starker, more alien world, a reminder that even our closest companion has a face that it keeps hidden from us, a secret side turned always toward the vastness of space. The familiar face it does show us is a landscape of profound texture, a surface covered in a unique and mysterious substance born from eons of silence and bombardment. That familiar face, the one that has gazed down upon our world for eons, is covered in a substance as unique and as ancient as the Moon itself. It is a fine, soft-looking blanket of powder that coats every mountain, every crater, and every vast, dark sea. We might call it dust, or soil, but it is fundamentally different from anything we know on Earth. It is the lunar regolith, the skin and memory of the Moon. This is not the soil of a living world, rich with organic matter and the processes of life. The regolith is a purely mineral creation, the product of 4.5 billion years of relentless, patient destruction. With no atmosphere to serve as a shield, the Moon has been subjected to a constant rain of cosmic projectiles, from large asteroids down to microscopic particles of dust, all traveling at immense velocities. Each impact, no matter how small, releases a tremendous amount of energy, pulverizing the solid rock of the lunar surface, chipping away at it, grinding it down, and slowly, over unimaginable timescales, creating the thick, powdery layer we see today. This blanket of debris is meters deep in most places, deeper in the ancient highlands and shallower in the younger maria, a testament to the cumulative history of cosmic violence. And the particles that make up this dust are unlike the soft, rounded grains of sand on an earthly beach. Here, the grains of sand have been tumbled by wind and washed by water for millennia, their sharp edges worn smooth. The particles of the lunar regolith have known no such gentle erosion. Under a microscope, they are revealed to be tiny, jagged shards of rock and glass, with razor-sharp edges, as fresh and as cutting as the moment they were fractured from their parent rock. They are so abrasive, in fact, that they posed a serious challenge to the Apollo astronauts, wearing away at the layers of their boots, clogging the seals of their equipment, and scratching the visors of their helmets. This strange dust has other curious properties, born from its long exposure to the raw space environment. Bombarded by the unfiltered ultraviolet radiation from the sun and the constant stream of the solar wind, the individual grains of dust become electrostatically charged. This charge makes them incredibly sticky, causing them to cling to everything they touch, much like tiny pieces of styrofoam. The Apollo astronauts returned from their moonwalks completely coated in a fine, grey powder that was incredibly difficult to brush off. This electrostatic effect may even be strong enough to levitate the finest dust particles a few centimeters above the lunar surface, particularly at the terminator, the moving line between lunar day and night, creating what scientists theorize could be ethereal dust fountains in the twilight. And perhaps most surprisingly, for a world defined by its silence and emptiness, this ancient dust has a smell. It is a scent that no human had ever experienced, until the moment the Apollo astronauts returned to their lunar module, bringing the dust inside with them. As they repressurized the cabin and removed their helmets, they were met with a distinct and pungent aroma, one they consistently described as smelling like spent gunpowder or the scent of wet ashes in a fireplace after a rain. This smell was likely the result of the fresh, unoxidized dust, which had been in a perfect vacuum for billions of years, suddenly reacting with the moist, oxygen-rich air of the cabin, a kind of rapid oxidation that released a scent from the very rock itself. It was the smell of another world, the scent of pure ancient geology. Within this dust, we find not just shattered rock, but tiny, glassy spheres and teardrops, formed from molten rock flung into space during an impact, as well as complex, welded particles called agglutinates, microscopic structures that tell the story of the regolith's violent and constant churning. This dust is more than just a covering. It is the moon's archive, a library of cosmic history where every grain holds a record of the sun and the stars. And within this ancient, dusty library, hidden in the coldest and darkest of places, the moon has kept its most profound secret. For most of human history, we believed the moon to be a world of absolute dryness. It seemed a logical conclusion. On its sunlit side, surface temperatures soar to over 120 degrees Celsius, hot enough to boil water instantly. In the perfect vacuum of its non-existent atmosphere, any water or ice would not even melt into a liquid, but would sublimate, turning directly into a gas and being immediately stripped away by the solar wind and lost to space forever. The Apollo samples, billions of years old and baked dry by the sun, seem to confirm this. The moon, we thought, was bone dry, a world utterly devoid of the most essential ingredient for life as we know it. But the universe is often more subtle and more surprising than our assumptions allow. In the final decades of the 20th century, and with much more certainty in the early years of the 21st, a series of orbiting space probes began to send back data that hinted at an incredible possibility. They found evidence not of liquid water, but of water ice, hidden away in the one place on the moon it could possibly survive, in the eternal darkness and the profound cold of the lunar poles. Near both the moon's north and south poles are deep impact craters whose floors are never touched by the direct light of the sun. This is possible because the moon's axis is tilted by only a tiny amount, just 1.54 degrees, compared to Earth's much more pronounced 23.5 degrees. Because of this minimal tilt, the sun, as seen from the lunar poles, always hangs right on the horizon, circling around and never rising high in the sky. For the deepest craters, the sun never clears the crater rim, and their floors are cast in a perpetual shadow, a darkness that has remained unbroken for potentially billions of years. These places are called permanently shadowed regions, and they are among the very coldest places yet discovered in our entire solar system. With no sunlight to warm them and no atmosphere to hold heat, temperatures within these shadows plummet to as low as minus 240 degrees Celsius. They are perfect cosmic cold traps. Any volatile compound, like water, that happens to find its way into one of these regions is instantly frozen solid and trapped, perhaps indefinitely. But where did this water come from? The evidence points to two primary sources, one from without and one from within. The first is celestial delivery. Over its long history, the Moon, like the Earth, has been constantly bombarded by comets and water-rich asteroids. These visitors from the outer solar system are essentially large, dirty snowballs, rich in frozen water and other ices. When one of these objects strikes the Moon, the impact releases a vast cloud of water vapor. While most of this vapor is quickly lost to space, some molecules would drift randomly across the lunar surface, and any that happened to wander into a permanently shadowed crater would be immediately captured by the extreme cold, freezing onto the surface and adding, molecule by molecule, to a growing deposit of ancient ice. The second source is even more fascinating. It is a process that may be creating water on the Moon right now. The solar wind, as we know, is a constant stream of particles flowing from the Sun, and it is largely composed of hydrogen ions, which are simply protons. As these hydrogen ions continuously strike the lunar regolith, they interact with the abundant oxygen that is locked away in the silicate minerals of the soil. This interaction can, under the right conditions, form the hydroxyl molecule, which is one oxygen atom bonded to one hydrogen atom, and can sometimes go on to form a full water molecule, H2O. These molecules, created by the Sun's own breath touching the Moon's dusty face, can then migrate across the surface and also become trapped in the polar shadows. This discovery has fundamentally changed our relationship with the Moon. It is no longer a completely barren rock, but a world that holds a precious, life-sustaining resource. This hidden water could one day be harvested by robotic or human explorers, providing drinking water, breathable oxygen, and the fundamental components of rocket fuel, making the Moon a true stepping stone to the rest of the solar system. It is a quiet reminder that even in the most desolate of places, there can be a hidden reservoir of possibility, a subtle sign of a world that is not as still or as dead as it might first appear. That hidden reservoir of ice, a substance we associate so closely with life and movement, is a quiet contradiction to our image of the Moon as a static, unchanging world. For centuries, we have called it a dead world, a place where geology has ceased. There are no active volcanoes painting the plains with fresh lava, no tectonic plates shifting to build new mountains or open new valleys. And yet, when the first human missions to the Moon placed seismometers upon its surface, those delicate instruments began to listen to the deep, silent interior, and they heard a profound secret. The Moon is not entirely still. It trembles. It shivers. It experiences thousands of moonquakes every year, faint and ancient heartbeats from a world that is still, in its own slow way, alive. The most common of these tremors are the deep moonquakes, which originate far below the surface, more than 700 kilometers down in the brittle lower mantle. These are not powerful events, barely perceptible by our standards, but they are rhythmic and predictable. They occur with a regular monthly cycle, their frequency peaking every time the Moon is at its closest and farthest points in its orbit around the Earth. These deep tremors are the direct result of the tidal forces we feel in our oceans, but here, it is the solid body of the Moon being squeezed and stretched by the relentless gravity of our own planet. It is as if the Earth is constantly plucking at the deep, ancient strings of the Moon's interior, and the seismometers were listening to the faint, resulting music. Much rarer, but also much more powerful, are the shallow moonquakes. Occurring only 20 to 30 kilometers below the surface, these quakes can be surprisingly energetic, reaching up to 5.5 on the Richter scale, strong enough to make the ground visibly shake. Their cause is not tidal, but tectonic. They are the groans of a world that is still, after 4.5 billion years, losing its primordial heat to space. As the Moon's interior slowly cools, it contracts, and this gradual shrinking causes its rigid, brittle outer crust to buckle and crack, creating stress faults that can suddenly slip, releasing centuries of accumulated tension in a single, violent shudder. The lunar surface also experiences its own gentle tremors. As the 2-week-long lunar day dawns, the frigid crust, which had been cooled to below -170 degrees Celsius, is suddenly exposed to the full, intense heat of the sun. As it rapidly heats up to over 120 degrees Celsius, the rock expands, causing tiny cracks and shifts that the seismometers could detect. These are thermal quakes, the gentle creaks and groans of a planetary body breathing in the heat of the sun. And finally, the seismometers listen to the sounds of the cosmos itself, faithfully recording the sharp vibrations from every meteorite that struck the surface, turning each impact into a known data point that allowed scientists to map the lunar interior. By studying how the seismic waves from all these different quakes traveled and bounced through the moon, we were able to confirm its layered structure, to measure the thickness of its crust, the depth of its mantle, and to prove the existence of its small, partially molten core. And in this data, we found one last surprise. Moonquakes last for a very long time. An earthquake on our planet is usually over in less than a minute, its energy quickly absorbed by our world's warm, wet, and plastic interior. But on the cold, dry, and fractured moon, there is very little to dampen the vibrations. A single moonquake can cause the entire world to ring like a bell for 10 minutes, or sometimes even longer, its ancient shivers echoing through its silent, stony heart. This is the sound of a world slowly, gracefully settling into its final, quiet old age. Those ancient shivers, which ripple through the solid body of the moon, eventually fade into the profound and overwhelming stillness of its external environment. It is a stillness born of an almost perfect emptiness. What we might call the moon's atmosphere is, by any earthly standard, a vacuum. Known more accurately as a surface boundary exosphere, it is a fantastically tenuous layer of individual atoms and molecules, with a total mass of less than 10 metric tons spread around the entire world. The density is less than 1/100 trillionth of the atmosphere here on Earth, so sparse that the atoms themselves almost never collide with one another. They are like solitary ghosts, sourced from the radioactive decay of elements in the crust, or knocked loose from the surface by the sputtering impact of solar wind particles, and they drift on ballistic trajectories until they either strike the surface again or are lost to space. This beautiful emptiness creates an environment of absolute and unwavering silence. Sound, as we experience it, is a pressure wave, a vibration that needs a medium, like air or water, to travel. In the vacuum of the moon, there is no medium. A tumbling rock cascading down a crater wall, a spacecraft landing its entire weight upon the surface, even a hypothetical explosion, would all occur in a silence so complete it is difficult for us to imagine. It is a world without echo, without reverberation, a realm of pure, undisturbed quiet that offers a sense of both profound isolation and unparalleled peace. This lack of an atmosphere to mediate the environment leads to the most extreme contrasts. There is no air to trap heat or to distribute it through winds and weather systems. The difference between sunlight and shadow is therefore absolute and instantaneous. To stand with one foot in the sun and one in the shadow would be to experience a temperature difference of nearly 300 degrees Celsius. In the unfiltered glare of the sun, the grey dust can heat up to over 120 degrees Celsius, while in the adjacent shadow, just a single step away, the temperature instantly plummets to below -170 degrees. It is a landscape of the most brutal and magnificent extremes. And with no air, there is no weather. There is no wind to stir the ancient dust, no clouds to veil the sky, no rain to wash the mountains. The sky itself is not the gentle blue we know, which is a product of our atmosphere scattering sunlight. On the moon, the sky is always, unchangeably, black. Even with the sun shining brilliantly above, the sky remains a deep, velvet black, studded with the sharp, unwavering lights of the distant stars and the brilliant, marbled globe of the Earth, hanging like a giant jewel in the void. This raw, unfiltered environment means the lunar surface is constantly bathed in the full spectrum of solar radiation and peppered by high-energy cosmic rays from the farthest reaches of the galaxy. It is a hostile place for life, but it is also a place of pristine connection, an unparalleled observatory from which to gaze out into the universe, with nothing to dim the view. It is a world stripped down to its essential elements: rock, silence, and the unfiltered light of the cosmos, a stark and simple palette of grey and black. And yet, within this seemingly monochrome world, hidden from the naked eye, lies a subtle and secret spectrum of colour. The stark, beautiful emptiness of the moon, with its palette of brilliant light and absolute shadow, seems to present a world devoid of color, a perfect monochrome study in grey. To our eyes, whether we are looking up from our backyards or gazing at the stunning high-resolution photographs taken by orbiters and astronauts, the lunar surface appears to be a subtle gradation of charcoals, silvers, and whites. This perception is partly the truth of our own biology. In the dim light of a moonlit night, our color-sensing cone cells give way to our light-sensing rod cells, washing the world in shades of grey. And even in photographs, the overwhelming brightness of the sunlit rock tends to bleach out the incredibly subtle variations in hue that truly exist there. But the grey is an illusion, a limitation of our own senses. For if we could see the moon with eyes capable of perceiving the full, nuanced story of light, we would discover that it is a world painted in a secret, subtle spectrum of colour. To uncover this hidden palette, scientists use powerful tools like multispectral imaging and spectroscopy. These instruments can analyze the light that is reflected from the lunar surface, not just in the visible spectrum we can see, but across a wide range of wavelengths. Every mineral has a unique spectral fingerprint, a specific way that it absorbs and reflects different colors of light. By capturing this data from orbit, scientists can create a detailed mineralogical map of the entire moon. To make this invisible data understandable to our eyes, they assign visible colors like red, green, and blue to different spectral wavelengths, and then dramatically increase the saturation. The result is a breathtaking, enhanced, false color image that transforms our grey companion into a work of geological art. In these vibrant images, the moon's story is told in color. The vast, dark plains of the Maria, once thought to be uniform seas of basalt, are revealed to be a complex mosaic of different lava flows. Some regions, like the Sea of Tranquility where Apollo 11 landed, blossom into a deep and beautiful blue. This blue hue is the spectral signature of a mineral called ilmenite, a titanium and iron oxide. These blue plains are the remnants of ancient lava flows that were exceptionally rich in titanium. In other areas, the Maria glow with a soft orange or a deep, rusty red. These are the signs of different volcanic eruptions, flows that were also rich in iron but relatively poor in titanium. The colors allow us to trace the boundaries of these ancient lava seas, to see how one flow overlapped another, revealing a complex and dynamic volcanic history. In striking contrast, the ancient, bright highlands show very little color at all in these images, appearing as a pale, creamy white. This reflects their different composition, the anorthosite rock of the primordial crust, which is rich in calcium and aluminum, but poor in the heavy, metallic elements like iron and titanium that create the stronger colors. And splashed across this entire canvas are the brilliant, stark streaks of the youngest impact craters. A feature, like the magnificent ray system of Tycho crater, which is almost invisible in terms of color to the naked eye, appears in these enhanced images as a network of bright, ghostly blue-white lines. This brightness is the mark of youth. The material blasted out of the crater is fresh, unweathered rock that has not yet been subjected to the slow, darkening and reddening effects of space weathering from the solar wind and micrometeorite bombardment. Color, on the moon, is a clock. It tells us not just what a place is made of, but how long it has been exposed to the harsh environment of space. It reveals the moon to be not a world of uniform grey, but a masterpiece of subtle geology. A silent world that is whispering its history in a language of colour we are only just beginning to learn. And this story of slow, inexorable change, written in the very dust of the moon, is a small echo of a much grander, much slower transformation happening in the very architecture of the Earth-Moon system itself. The slow and steady process of space weathering, which gradually alters the colour of the lunar surface over millions of years, is a powerful reminder that even on a world that seems frozen in time, change is the only true constant. And this principle applies not just to the moon's surface, but to its very orbit, to its fundamental relationship with the Earth. In one of the most profound and gentle discoveries of modern astronomy, we have learned that the moon is leaving us. It is a slow, almost imperceptible departure, a long goodbye written into the very laws of physics. Every year, our silent companion drifts just a little bit farther away from us. The current rate of this recession is about 3.8 centimeters per year, a distance so small that it is roughly the same speed at which a human fingernail grows. You could not possibly notice it by looking up at the sky tonight, or next year, or even in 100 years. But over the vastness of geological time, this tiny annual retreat adds up to a fundamental reshaping of our celestial neighborhood. The reason for this slow separation is a beautiful and intricate dance of energy and gravity, a direct consequence of the very same tides that the moon raises in our oceans. As we have explored, the moon's gravity pulls on Earth's oceans, creating two tidal bulges. But the Earth is spinning on its axis much faster than the moon is orbiting around it. This rapid rotation drags the tidal bulges slightly ahead of the moon in its orbit. So, there is always a large bulge of ocean water just in front of the moon. And this bulge has its own significant mass, and therefore its own gravitational pull. This forward-positioned mass of water acts like a gentle, persistent tug, pulling the moon forward and accelerating it ever so slightly in its orbital path. This constant, tiny acceleration has a seemingly paradoxical effect. In space, if you speed up an object that is in a stable orbit, you do not cause it to fall inward. You cause it to climb into a higher, more distant orbit. The energy that is being added to the moon's orbit has to come from somewhere, and it comes from the Earth's own rotation. This entire process is governed by one of the most fundamental laws of the universe, the conservation of angular momentum. The total amount of rotational momentum in the Earth-Moon system must remain constant. So, as the tidal friction steals momentum from the Earth's spin, slowing our day by a few milliseconds per century, that exact amount of momentum is transferred to the moon's orbit, pushing it farther away. It is a perfectly balanced exchange of energy, a gravitational conversation between planet and satellite. Looking back into the deep past, this means the moon was once much, much closer to the Earth. 4 billion years ago, it would have appeared as a colossal, breathtaking object in the sky, perhaps 16 times larger than it appears today, and the Earth's day may have been as short as 5 or 6 hours. The tides it raised would have been thousands of times more powerful, vast walls of water that swept across the globe, perhaps playing a crucial role in the mixing of the primordial oceans where life first began. And looking into the distant future, billions of years from now, the moon will appear noticeably smaller and fainter. In a sky, it will cross much more slowly, as the Earth's day will have lengthened to be many hours longer than it is now. An inevitable consequence of this slow retreat is that the era of perfect total solar eclipses is a temporary gift. In about 600 million years, the moon will have drifted far enough away that its apparent disk will be too small to completely cover the face of the sun. This long, slow and graceful goodbye is not an ending, but an evolution, a reminder that our connection to the moon, as constant and as timeless as it feels, is a dynamic and ever-changing relationship. It is a world in motion, its face not only telling stories of the past but also hiding mysteries we are still working to unravel. This ever-changing, ever-evolving relationship between the Earth and Moon is a grand, slow dance of gravity and time. But on the surface of the Moon itself, there are features that seem to defy this relentless march of time, beautiful and enigmatic patterns that hint at a different kind of celestial secret. In several places across the lunar surface, particularly within the dark Maria, we find some of the most mysterious and visually stunning formations in the solar system, the lunar swirls. They are bright, intricate, and almost ethereal patterns of high albedo soil that curve and loop across the grey dust, like brushstrokes of white paint on a dark canvas. Some are small and delicate, while others, like the famous Rhina Gamma in the Ocean of Storms, form a complex winding pattern, hundreds of kilometers long. They have no discernible height or depth. They are not craters or mountains, but purely superficial markings, almost like tattoos on the moon's ancient skin. For a long time, these swirls were a complete puzzle. We know that the lunar surface is constantly being darkened by space weathering, the slow but steady bombardment of solar wind particles and micrometeorites that churns and alters the regolith. Any bright feature should, over the course of millions of years, be erased, blended back into the uniform grey of its surroundings. Yet the swirls persist, maintaining their bright, youthful appearance as if they were created only yesterday. They seemed to be somehow protected from the aging process of the cosmos, but the mechanism was a profound mystery. The key to unlocking this puzzle came not from cameras, but from magnetometers, instruments designed to measure magnetic fields. As spacecraft orbited the Moon, they detected something astonishing: a series of strong, localized magnetic anomalies, pockets of powerful magnetism rooted in the lunar crust. And when scientists mapped these magnetic fields, they discovered a perfect, one-to-one correlation. Every single lunar swirl on the Moon exists in a place where the crust is strongly magnetized. This discovery gave rise to a beautiful and elegant explanation known as the magnetic shield hypothesis. The Moon, as we know, no longer has a global magnetic field to protect it. But these localized magnetic anomalies act as tiny, individual magnetic umbrellas. They create a miniature magnetosphere that extends just a few hundred kilometers above the surface, a magnetic bubble that is strong enough to deflect the charged particles of the solar wind, forcing them to flow around the protected region. Since the solar wind is one of the primary causes of space weathering and the darkening of the regolith, this magnetic shield dramatically slows down the aging process for the soil directly beneath it. The bright, sinuous patterns of the swirls, therefore, are quite literally the shadows of these invisible magnetic fields, regions of the surface that have been preserved in a more pristine, youthful state, while the area around them has slowly weathered and darkened over the eons. But this elegant solution only leads to a deeper question. Where did this fossil magnetism come from in the first place? How did a world with no active dynamo get these powerful magnetic tattoos? One possibility is that they are the last lingering ghosts of the Moon's ancient global magnetic field, which may have been active in its first billion years of life, and somehow became permanently imprinted in certain iron-rich rocks as they cooled. A more dramatic theory suggests that the anomalies were created by the impacts of comets. The high-velocity collision of a comet's gas and plasma cloud with the lunar surface could have generated an incredibly powerful, temporary magnetic field at the impact site, a field that was then permanently frozen into the molten, iron-rich rock created by the impact. Whatever their origin, these magnetic whispers from the Moon's distant past serve as a final, wondrous puzzle as we turn our gaze away from the Moon as a world of rock and dust and begin to explore its more subtle, more mysterious influence on the world of life itself. These faint, ghostly echoes of magnetism, which shield and preserve the Moon's own surface, serve as a beautiful metaphor for the equally subtle, but far more profound, influence the Moon has had on the living surface of our own world. For this final part of our journey, let us draw our focus away from the distant, silent plains of the Moon itself and return home to the warm, wet, and vibrant biosphere of the Earth. Let us drift down through our own atmosphere and listen not for the tremors of a cooling world, but for the biological rhythms that seem to beat in time with our celestial companion. For billions of years, life on Earth has evolved under the constant, cyclical presence of the Moon, and its rhythms of light and gravity are woven deeply into the fabric of the natural world. Nowhere is this connection more clear than in the depths of our oceans, the very place where life began. The most spectacular example of this lunar dance takes place in the warm waters of the Great Barrier Reef. For 1 or 2 nights a year, just after the full moon in late spring, the entire reef, for hundreds of kilometers, engages in a magnificent and perfectly synchronized act of mass spawning. Guided by a combination of water temperature and the unmistakable light of the full moon, countless corals simultaneously release their eggs and sperm into the water, creating an underwater snowstorm of potential new life. It is a breathtaking spectacle of coordination, a planetary-scale reproductive event conducted by the silent light of the moon. And the corals are not alone. The grunion, a small, silvery fish found off the coast of California, times its reproductive cycle to the highest of the high tides, the spring tides created by the alignment of the sun and moon. During these nights, they ride the waves onto the sandy beaches, lay their eggs in the wet sand, and return to the sea, confident that their nests will remain undisturbed until the next spring tide arrives to trigger the hatching. The very zooplankton that form the base of the oceanic food web migrate up and down in the water column in a daily rhythm that is modulated and timed by the phases of the moon. This lunar influence extends beyond the ocean's edge. Even on land and in the air, life has learned to read the moon's subtle language. Many nocturnal animals are more active during the brighter nights of the full moon, while others prefer the cover of the new moon's darkness. And some have evolved a relationship with moonlight that is truly astonishing. The humble African dung beetle, for example, has been shown to possess one of the most remarkable navigation systems in the animal kingdom. On clear, moonlit nights, these beetles can roll their dung balls in perfectly straight lines, an essential skill for escaping the competition at the dung pile. They achieve this feat by using the faint, polarized light of the moon as a celestial compass. The light from the moon becomes polarized as it scatters through Earth's atmosphere, creating a faint pattern in the sky that is invisible to our eyes, but perfectly clear to the beetles, providing it with a reliable and constant directional guide. This deep, instinctual connection to the moon also echoes within our own species. For millennia, human culture, folklore, and even language have been filled with the belief that the moon influences our minds and bodies. The very word lunacy stems from luna, the Latin name for the moon. While the idea of the full moon causing madness has been largely relegated to myth, the scientific question of a more subtle lunar effect continues to be a subject of gentle inquiry. Some recent studies have suggested a very subtle correlation between the lunar cycle and human sleep patterns, finding that around the time of the full moon, people may take slightly longer to fall asleep and experience slightly less deep sleep, even in perfectly dark laboratory settings. The evidence is far from conclusive, but the persistence of the question itself speaks to a deep and ancient feeling that we are tied to this rhythm, a biological clock that still faintly ticks in time with that distant, silent world. This deep and ancient biological rhythm, which the moon seems to conduct from afar, connects the life of our world to the steady, predictable cycles of the cosmos. The moon, in this sense, is a keeper of time for the living, but it serves another, even more profound, role as an archivist. It is a keeper of a much deeper kind of time, a silent and perfect museum of the history of our solar system. Our own planet, the Earth, is a world of constant, restless change. Its surface is forever being reborn. The slow, powerful march of plate tectonics consumes old crust and forges new mountains. The patient, relentless forces of wind and water, of rivers and glaciers, wear those mountains down to dust. And the ceaseless activity of life itself covers the land, digests the rock, and erases the past. The Earth is a poor keeper of its own long-term history. Its memory is shallow because its surface is always being wiped clean. The moon, however, is the complete opposite. It is a world in near-perfect stasis. Its geological engine has fallen silent, and most importantly, it is an airless, waterless world. With no atmosphere, there is no weather. There is no wind to sculpt the rock or blur the sharp edges of a crater rim. There is no rain to fall, no rivers to carve canyons, no ice to grind the mountains into sand. Every feature on the moon, unless disturbed by a new impact, is preserved in a state of almost absolute fidelity. It is this profound stillness that makes the moon the most pristine and valuable museum in our solar system. The most important exhibit in this silent museum is the unvarnished history of cosmic impacts. The bright, battered highlands, in particular, are a window into a time known as the Late Heavy Bombardment, a violent era that ended some 3.8 billion years ago, when the last of the large debris in the young solar system was swept up by the planets and their moons. The Earth undoubtedly endured this same cataclysm, but almost all evidence of it has been erased by billions of years of erosion and tectonic activity. On the moon, the record of this ancient assault is preserved with perfect clarity in its countless overlapping craters. By painstakingly counting, measuring, and dating these craters, scientists have been able to reconstruct the history of our cosmic neighborhood, learning just how violent and chaotic the solar system's youth truly was. The rocks themselves, brought back to Earth by the Apollo missions, are priceless artifacts from this museum. While most of Earth's surface rocks are relatively young, the moon offers us samples that are billions of years old, dating back to the very dawn of the solar system. One of the most famous of these is the sample known as the Genesis rock, a piece of anorthosite collected by the astronauts of Apollo 15. They knew from its crystalline structure that it was ancient, and they believed it might be a piece of the moon's original, primordial crust. While later analysis showed it to be a little over 4 billion years old, not quite a Genesis rock but still among the oldest materials ever handled, the story of its discovery captures the profound thrill of reaching across time, of holding a piece of the solar system's earliest moments in a human hand. And this silent museum does not only preserve the history of the cosmos, it now also preserves our own. Because there is no wind to blow it away and no water to wash it clean, every trace of humanity's presence on the moon remains exactly as it was left. The landing sites of the 6 Apollo missions are now silent, motionless historical monuments. The descent stages of the lunar modules sit peacefully on the plains, their gold foil still gleaming. The lunar rovers are parked exactly where their last mission ended, covered in a fine layer of grey dust. Scientific instruments still stand, waiting for a command they will never receive. And most poignantly of all, the footprints of the 12 men who walked there are still pressed into the fine lunar soil. These footprints, the first marks of humanity on another world, will remain undisturbed for millions of years, perfectly preserved by the beautiful emptiness around them, a quiet and enduring testament to a time when we first stepped away from our home and into the great, silent museum of the sky. This silent, patient world, which has so perfectly recorded the physical history of impacts and the first tentative footprints of humanity, has also served another, more intimate purpose. It has been a passive canvas, but it has also been an active mirror. For as long as we have been a species capable of looking up and wondering, we have gazed upon the moon and seen not just a sphere of rock, but a reflection of ourselves. It has been the silent confidant for our dreams, the screen onto which we have projected our most profound stories, our deepest fears, and our greatest hopes. The connection begins with a simple trick of the human mind called pareidolia, our innate tendency to perceive meaningful patterns, and especially faces, in otherwise random arrangements of light and shadow. It is why we see animals in the clouds, and it is why nearly every human culture throughout history has seen a face or a figure in the dark patches of the lunar maria. In Western cultures, it is most often the man in the moon, a simple, friendly face gazing down. But other cultures have projected their own stories onto that same canvas. In East Asia and in the ancient cultures of Mesoamerica, many people see a rabbit, sometimes pounding the elixir of life in a mortar and pestle. Other traditions have seen a woman weaving at a loom, a great frog, or 2 young children carrying a bucket of water. These are not just quaint fairy tales. They are evidence of a universal human impulse to make the cosmos familiar, to find a relatable, living presence in the cold, silent face of the night sky. From this simple act of recognition, we wove the moon into the very fabric of our spiritual lives. It became one of our first and most powerful deities. The ancient Greeks had Selene, who drove her silver chariot across the sky, and the huntress Artemis, the powerful goddess of the moonlight. The ancient Egyptians looked to Thoth, the god of wisdom, writing, and magic, whose curved ibis beak was often linked to the crescent moon, and who was seen as the one who measured time. In China, there is the enduring and beloved story of Chang'e, the beautiful goddess who, through a tragic accident, flew to the moon and now lives there in a lonely but beautiful crystal palace, with only her jade rabbit for a companion. These myths were humanity's first great poems about the universe, our way of building a deep, emotional, and personal relationship with the celestial bodies that govern the rhythms of our world. As our societies grew and changed, the moon's role shifted from a deity to be worshipped to a muse to be celebrated. It has been a constant and unwavering source of inspiration for our art, music, and literature. It has symbolized the purity of romance and the ache of unattainable love. It has been a symbol of madness and transformation, the celestial trigger for the werewolf's change, its cool light illuminating the darker, more primal aspects of our nature. It has been a symbol of profound solitude, a companion for the lonely, and a symbol of the sublime, that mixture of awe and terror we feel when we contemplate the vast, silent emptiness of the universe. And in a beautiful, circular way, even our modern, scientific understanding of the moon can be seen as another form of this same human impulse for storytelling. The giant impact hypothesis is not just a scientific theory, it is a grand and violent creation myth, a story of cosmic birth that is every bit as epic as the ancient legends. When Galileo first turned his telescope to the moon and drew its mountains and its craters, he was not just recording data, he was telling a revolutionary new story that forever changed our understanding of the heavens and our place within them. Our scientific quest to understand the moon's geology, its chemistry, and its history is our modern way of continuing this ancient conversation, of trying to connect with and make sense of that silent, luminous face in the sky. It has always been both a physical destination and a destination for the human imagination, a world of rock and dust that also serves as a perfect silver mirror for the soul. That silver mirror, which has for so long reflected the stories of our past and the dreams of our imagination, is now once again becoming a destination for our future. For a brief, shining moment in human history, during the Apollo era, we left our world and set foot upon that silent shore. It was a journey of pure exploration, a magnificent gesture to prove that it could be done. And then, for half a century, we fell silent, content to gaze from afar. But that silence is now ending. A new era of lunar exploration is dawning, with missions like NASA's Artemis program leading the way for a global return to the moon. This time, however, the goal is not just to visit. The goal is to stay. We are no longer going simply to plant flags and collect rocks, but to build a sustainable, long-term human presence on another world. To learn how to live and work in the beautiful emptiness of space. This return is driven by a new and deeper set of ambitions. The scientific questions have evolved. We now wish to establish a permanent observatory on the moon's far side, the most radio-quiet place in the inner solar system. Shielded from the constant electronic chatter of our own planet, a radio telescope there could listen to the faint primordial whispers from the very dawn of the universe, light that has been traveling for more than 13 billion years, a signal that is completely inaccessible from the surface of the Earth. But perhaps the most profound shift in our thinking is the concept of learning to live off the land. This idea, known as in situ resource utilization, is the key to a permanent human future in space. We now know the moon holds reservoirs of water ice in its polar shadows. This is more than just a scientific curiosity. It is a strategic resource of immense value. From this ice, future lunar inhabitants could extract drinking water and breathable oxygen for their habitats. But even more importantly, by splitting the water molecule into its constituent parts, hydrogen and oxygen, they could create the two primary components of powerful and efficient rocket propellant. This would, in effect, turn the moon into a refueling station in the sky, a place where spacecraft could top up their tanks for much longer and more ambitious journeys into the solar system, most notably to Mars. We have also learned that the lunar regolith itself can be a valuable building material, capable of being sintered by lasers or microwaves and used in 3D printers to construct landing pads, habitats, and radiation shields, reducing our reliance on heavy materials that must be launched at great expense from Earth. The moon, in this new vision, is the essential proving ground, the stepping stone on our path to becoming a multiplanetary species. It is close enough to home, only a 3-day journey away, that a rescue is feasible in an emergency. Yet it is also a truly alien world, with its vacuum, extreme temperatures, and harmful radiation, providing the perfect place to test the technologies, the life support systems, and the resilience of the human spirit before we take the much greater leap of a multi-year mission to Mars. Becoming a two-world species is not just a technological challenge, it is a profound philosophical step, a way of ensuring the long-term survival of consciousness and the precious biosphere of Earth by establishing a second, independent foothold for life in the cosmos. The first permanent lunar base will be more than a scientific outpost. It will be the first off-world extension of human culture, a place from which to look back and see our own world, whole and beautiful and fragile, hanging in the velvet darkness. That breathtaking image of the Earth rising over the lunar horizon, the Earthrise first captured by the astronauts of Apollo 8, is perhaps the most precious gift the moon has given us. In our long journey to understand our nearest celestial neighbour, we ultimately discovered our own planet. We have come full circle now in our gentle story tonight, from gazing up at that luminous anchor in our sky to standing on its silent surface and looking back at the distant, swirling blue marble of home. We have travelled back in time to witness its violent, fiery birth from a great cosmic collision, and we have felt its invisible gravitational pull that raises the slow, steady breath of our oceans. We have walked across its dark, frozen seas of lava and stood among its ancient, battered mountains. We have listened for the faint, deep shivers of its cooling heart, and we have learned that its soft, silvery light is merely the borrowed glow of a distant star, transformed into magic by our own eyes. We have uncovered its most profound secret, the reservoirs of ancient ice hidden in its eternal shadows, and we have seen how its stark, grey face is actually a canvas of hidden, subtle colour. We have understood it as a museum that preserves the history of the cosmos, and as a mirror that reflects the evolution of our own consciousness. In the end, we see that the Earth and Moon are not two separate worlds, but a single, interconnected system, a double planet locked in a gravitational embrace since their shared beginning. They have co-evolved, each shaping the destiny of the other. And in fact, the Moon's quiet, constant presence may be one of the most important reasons that we are here at all. The gentle, stabilizing pull of its gravity has acted like a gyroscope for our planet, holding the tilt of Earth's axis steady over geological eons. Without the Moon, our planet's tilt might have varied chaotically, leading to wild, catastrophic swings in climate that could have made the long, stable evolution of complex life impossible. Our silent companion, in a very real sense, may have been our guardian, the anchor that held our world steady enough for consciousness to emerge and to one day look up and wonder about its origins. And so, the Moon remains. It is a universal heritage, a light that shines down on all of us, on every continent and every culture, a shared symbol of peace and of our own enduring, limitless curiosity. And as you now let your own mind drift into the quiet stillness of the night, perhaps you can picture it one last time. That familiar, luminous disk, hanging in the silence. It is no longer just a light, but a world. It is a story, a destination, a mirror. It is our past and our future. It is the silent, watchful keeper of our planet's deepest rhythms, and the steadfast companion to our own lonely and beautiful journey through the cosmos. Thank you for joining me on this journey this evening. I hope it has brought you a measure of peace. If you've enjoyed our time together, please do consider leaving a like and subscribing to the channel for more gentle stories. For now, I wish you the very deepest and most restful sleep. Good night.